Hello, ladies and gentlemen, and welcome back. I hope you're all doing well. We're midway through our Part C questions, and we are up to question 23. Zeus starts at the origin, 0, 0, and can make repeated moves of 1 unit either up, down, left, or right, but cannot make a move in the same direction twice. For example, he cannot move from 0, 0 to 1, 0 to 2, 0, because that would be going to the right twice. What is the smallest number of moves that he can make to get to the point 1056, 1007? Interesting. Okay. So what can we do there? Let's get the question 22 out of the way. So we start at 0, 0. And so we can move 1 unit over to 1, 0, but we can't then follow that up with another move. And I think that's going to be the trick. Now, if we were trying to go, let's just look at a simpler case, and maybe I'll make use of a better grid for a moment, just so people can follow along. So Zeus starts here and then put some grid lines on here representing 1 unit length. Now suppose we wanted, Zeus wanted to go to 2, 2. If we want to do it the smallest number of ways possible, we'd just go directly there. Now we can't just go directly there, obviously. So, what we could do is 1 unit to the right, but we can't follow that up with another move to a unit to the right. But we could go up. We can't go up again, but we could go right. We could alternate. And that would quite easily get us to 2, 2 in 4 moves. If we wanted to go to 3, 2, which would be over here, 3 units over, 2 units up, we could just go right again. Now, if instead we wanted to go to 2, 3, which is this spot up here, we couldn't follow it up with a move up. But of course, who said we had to go that way first? We could go up, over, and then up, and that would be allowed. Okay? So we've got some options here. And you might at first, when working this out, make a bit of a guess that if you don't look at the right cases, I think you can very quickly sort of guess that, well, you just need, for 2, 2, it was a minimum of 4. For 3, 2, I could get there in 5. For 2, 3, I could find a way to get there to 5 in 5 as well. You know, for 1, 2, you go over, up, over. So it looks like the most direct way to get there would be the number of moves. You just need to count the number of moves up you go, or over, and the number of moves up, and that would add up to 5. So it looks like to get to AB, it takes A plus B moves. But there's the catch that you can't follow up the same move twice. So suppose I tried to go to something like, let's say, 2, 4. So that's 2, and we go up by 2. So I tried to go up here. The smallest number of moves possible. So if I want to go to 2, 4, in theory I should be able to do it in 6, if this nice little sort of result holds. Okay. So at most I'll do 2 moves to the right, and then I'll end up doing 4 moves up at some point. So, well, we've got to go up pretty far. So what if we start going up? Well, we can't go up again, so we got to go over. And we go up. And we can't go up again, so we got to go over. And then we go up, and we're almost there. We just need to go up again. Oh, wait, we can't. Well, maybe it's like that one question, or that one, and we just didn't pick the right path at the start. Okay? So maybe we'll start going over this way, and then up, and then over, and we're even further away. Okay, so we've got a bit of a problem. Now, one thing we can do is we could go back and go up, and then go over and go up, that would work. But we've added to our journey. We had to go back and then forth, and these sort of cancel each other out. We're actually using the move to the left action because we're trying to go too high without going too far over, and that's going to end up being the problem. Okay? So we're going to have a certain number of moves to cancel out. So, well, what could we say? Now, if we... So go to, what was it, 1056, I think it was 1007? Yes. Without restriction, needs, you just add them up, so 1056 plus 1007, and that'll be 2063 moves. Is 2063 one of the possibilities? It is. It's for the people who don't understand that you can't just take a certain number of rights and then a certain number of lefts, or a certain number of ups and combine them properly. So this needs some order of ups. Well, we know how many ups we need to go and how many overs we need to go. So 1056 rights and 1007 ups. But alternating will only get us so far. That's why, we started out alternating, but eventually we had to backtrack. Same thing would have happened here if we'd gone up, and then over, and then over, and then up. We'd have to backtrack by adding 3 moves that we, 3 moves here, 2 of which we don't want. We want 6, but it takes 8, no matter which way we seem to do this. There's a bit of a problem there. Okay. So... There's too many. In a sense, there's too many rights because you go right up, but eventually you've gone up as far as you need to go, but you still have a significant distance you need to move right. Okay. So what can we do? Well. We can move right up for 1007 times 2. So 1000 ups, or 1007 ups, 1007 rights, and that'll be 2014 right up. But then we need to move, so then we've gone up. We're at the right height. 107, so y equals 107, but we need to go further over. So just doing this, we'd be at 1007, 1007. We still have a considerable distance to go to get to 1056, 1007. We have 49 moves to go. How can we make this up? Well, I suppose the next move we could make could be a right. But we can't do another right. So we'll have to do an up or a down, doesn't matter which one. You don't want to go left, because then you're backtracking. We definitely want to always be moving right if we can. So no backs, but I guess we could move down, and then a right, and then an up, and then a right. And hopefully everything will match up. Okay? So we come back to this line after 4 moves. Every 4 moves we do that, and we move over by 2. 2 rights. So now, so over here we'd be at 1009, 1007. And then when we come back up, we'd be at 1011, 1007. Okay, and so we can keep doing this sequence of over, down, over, up. And we gain 2 rights each time at the cost of 4 moves. But here's the problem. You'll notice that our x-coordinate is increasing by 2. It started out as an odd number, and we're trying to reach 1056. So eventually we'll come back up, and we'll be at 1055, 107, and we'll need to move right again. It's okay, so that'll work out. I was worried that we weren't quite going to make it there. All right, so we'll have, for every 2 spaces right we go, we gain 4 moves, and then we also have this little extra right at the end. So 2014 moves to get here, plus 1 move over here, plus 4 moves for every 2 that we want to go over. Well, how many do we want to go over? 1056 minus 1007 minus this extra little bit. So minus 1. So it'll be 49. It'll be 48 divided by 2. And that'll be 24. So we've got 24 double rights to move over at the cost of 4 moves apiece. So 24 times 4. And that should give us an answer. So 2014 plus 1, that 1 move at the end, plus 24 times 4. 24 times 4 is 96. So we have 2014 plus 1 plus 96. That'll be 2015. 15 plus 96. And so that'll be add on 100. So that'll be 2115. But we didn't quite add on 100. We were 4 less. So 2111, I think, should be the smallest. Now, let's see. Is that one of the possibilities? It absolutely is. Smaller than this one, smaller than this one, smaller than this one. The only one that it's not smaller than is sort of the dud, did I not think this through at all, answer of C. So I'm completely confident I can do it in 2,111 moves. So D is going to be my answer. And there we go. So we got around their nice little restriction. And I'm ready for more math. Hopefully you are as well. If you need to take a break, that's okay. And in the future, you can just join me for question number 24 in the next video. So long for now.